My name is Salem. Today I will present to you my master project titled Personal Trainer with Gesture Recognition using the Kinect. Please feel free to stop me whenever you have any question. Okay. So, I'll first start with the problem. This is a problem.
Thank you for reminding me.
Yes. Okay. Each one of us either we're enrolled in a full-time job or just in our college study, or even just sitting at home doing nothing. Each one of us at least once we were faced with this problem, which is being overweight and losing fitness without doing exercise. The main problem is the ineffectiveness of doing exercise at home because there's no personal trainers that guide me whether this is correct, whether this is wrong. And the other solution is to go to the gym, which is troublesome for some people and for some people even costly to do. So, what this project aims to solve is the following. Is the main problem, which is the ineffectiveness of doing the main problem for doing exercises at home. When we thought about this problem, we thought that the main reason behind this problem are two reasons actually. First, it's the ineffectiveness because there's no personal trainers that guide me whether I'm doing it right or I'm doing it wrong. And the other problem is the lack of motivation. And after doing a couple of crunches, a couple of sit-ups, I stop. I don't have enough motivation to continue going on. So my project aims to solve those two problems. So the motivation behind this project is mainly, as I said, to solve the troublesome and ineffectiveness of doing exercises with the ease and comfort of being at home. This is done using the Microsoft Kinect, which I'll be talking in detail about later. The Microsoft Kinect offers a never offered before full body skeletal recognition that was never ever offered by any other type of camera. This project can help raise the fitness levels in the community and even save the regular fitness players that are going to the gym a few bucks by just doing the exercises at home. So mainly the aim is to first enhance the training at home experience by providing a feedback system that gives the user the feel and the whole experience of having a personal trainer at home. Also taking the body measurements on a periodic basis. This point mainly aims to solve the problem I stated earlier, which is the lack of motivation. What I thought of is taking the body measurement on a periodic basis, for example each week, each month, would help the user be motivated to continue working out and burn some more fat and burn some more calories to have better body measurements. In order to achieve those two aims, a proof of concept game was developed. A game was chosen to provide 3D graphics which would appeal to different users and interact with it in a nice and appealing way. Also, as I'm using the Kinect, which is the 3D camera, the whole experience had to be hands-free, meaning the player should not use any controller, shouldn't strap anything around his hand, around his side, around any part, and shouldn't go to the keyboard and press keystrokes and stuff like that. So the whole experience had to be hands-free, without using anything. Okay, so in this section I will be talking about the different architecture and different technologies I used throughout this project. And there's a lot of technical details in each one of them, so I'll just be scratching the surface. If you have any questions, please stop me. First, the Microsoft Kinect. The Microsoft Kinect is an Xbox 360 peripheral released in 2010. Microsoft said that the Microsoft Kinect will provide the users with a controller-free gaming and entertainment experience that was never ever felt or experienced before. This is thanks to two main features that the Kinect offers. First, the depth image, and second, the skeleton track. Okay, if we take a look at the components of the Microsoft Kinect, as you can see, the Microsoft Kinect contains three different types of camera. First is the infrared light emitter. Second is a camera sensor receiver that receives the infrared light. And third is a regular RGB camera. Also, the Kinect has a multi-array microphone to ease the communication of audio and audio recognition. It also has an on chipset on board of it, which acts as a Kinect spray. I'll be talking about in detail about each area. So first, the depth image, which is, as I said, the main advantage of the Kinect over any type of 3D camera released before. This is the depth image. As you can see, the depth image, the further the physical object from the Kinect, the darker the color it has in the depth image, and of course, vice versa. This depth image is calculated using a technique called light coding. Light coding technique is a technique developed by a company named PrimeSense. PrimeSense was originally the company that developed the sensor, which was called Prime Sensor. This company was later acquired by Microsoft, and they released the Microsoft Kinect using the Prime Sensor. So the depth image generation was done by PrimeSense, not by Microsoft. How this works, it's not really known as the algorithm is proprietary, but the main idea is that the infrared light source transmits invisible to the eye infrared light to the whole scene. It codes the whole scene with the infrared light. Then this infrared light is received by the sensor, which passes this data to the Kinect's brain, which is a chipset, on board. This chipset performs a sophisticated parallel algorithm that generates this depth image from the same regular image. Okay? Next is a skeletal recognition. As I said, the Kinect offered skeletal recognition that was not offered by any type of camera before. The skeletal recognition is done on a software level. It's mainly image processing algorithms that are run in parallel that guesses where is the different joints of the human body part is. So for example, as you can see here, it recognizes this is the leg, and this is another leg, this is the waist, this is the elbow, this is the hand, and it provided me with an API that I can return each and every joint position and each and every joint orientation in the 3D world. This is of course done, as I said, on a software level. It was done by Microsoft and it was done by PrimeSense. I will talk about that also in details. So, as mentioned earlier, the Microsoft Kinect is a peripheral for the Xbox 360. So, and our project was to make a PC game. So, a driver had to be used to connect the Kinect to the PC. There were only two choices when I started working on that project: the Open Kinect and the OpenNI/Night stack. The Open Kinect is an open source driver that was developed by the open source community shortly after the release of the Microsoft Kinect. It had all the basic features like the depth image, the RGB image. It could control the motor, the tilt, so it can move actually the Kinect up and down to adjust the scene. It also had access to the audio, the microphone in the Kinect. On the other hand, OpenNI/Night was an open source driver released by PrimeSense. As I told you, PrimeSense is the company behind the camera itself. They released their own software which provided skeletal recognition and of course other basic stuff like the depth image. So of course I couldn't use the Open Kinect because my project depended mainly on the skeletal recognition, so I had to go with the OpenNI/Night stack. The only problem is that the OpenNI/Night stack software lacked the microphone and audio, which was available in the Open Kinect, and also lacked the control of the motor and the tilt of the Kinect. But I had to use this because I had to use this skeletal. Okay, as I mentioned earlier, I'm doing a PC game, so I had to use a 3D graphics library to help with the 3D game development and abstract a lot of game development techniques that were irrelevant to this project. For this cause, I used the Aubrey 3D graphics library. It's written in C++, released under the MIT license. The main advantage of using the Aubrey 3D over any other 3D library is that it came already with a sample application that connects the 3D graphics library to the Kinect. So I didn't have to work out how could the graphics library connect to the Kinect. There was already a sample application, so this was used. Also, as I said, the OpenNI/Night stack that I've used didn't have access to the audio in the Kinect. So I depended on the speech recognition found in Microsoft Windows 7. What happens is the following. When the user is playing and wants to run a specific command, there's some specific commands that are listed, something like measure, the command measure. The user will voice the command measure, and then this is recognized using the Windows 7 built-in speech recognition, and Windows 7 will know that the user actually said the word and the phrase measure. This is then passed on to another application, which is called shoot. What shoot does is take this phrase that is recognized by Windows 7 and convert it into a keystroke that is sent to the game itself. Because what I want to achieve, what I wanted to initially achieve is that I have to press a key to do a specific thing and to run a specific algorithm. So I had to work around this by saying a command, and this is actually translated into a keystroke to the program using shoot as I said. So to sum it up, my solution is a 3D game that would appeal to different users and make them interact with the game in a better way. The game would come with a set of predefined moves recorded by trainers. Also, the user can record his own moves. So if I get the game and I have only 4 moves, I can record my own moves and train on them later on. I have the ability to do that. Also, there's a feedback system using gesture recognition that I've built. This feedback system will act as a personal trainer that will tell the user if the move that the user had just done is actually correct or not correct. And finally, the player measurements. As I told you, the player can trigger the system to look at me and measure different body parts and report with me the results. So, the architecture section. There's mainly 3 important features in this project: the body measurements, the push perspective, and the gesture recognition. I will be talking about each and every one, showing it off in a video. Okay. So first, the body measurements. As I told you, the body measurements aim is to take different measures of different body parts. As you can see here, this is labeled the different body parts that I actually measure: the 2 hands, the waist, and the 2 sides, and actually how tall is the player is. So to start and trigger this algorithm to work, the user has to stand in a specific pose, which is shown right here, which is like this. So I can detect the hands and detect the legs, and legs of course has to be separated so the algorithm could run. It's also worth mentioning that to run this algorithm and get accurate results, the user of course has to be wearing tight clothes, so the clothes don't come into the calculating of the distance of the different body parts. How it's done? Okay, I'll just use the word to explain how it's done. Okay, so if we have our window that has user right here, okay, so just imagine, assume that this is a regular OpenGL window. What happens is the window is drawn in a row major order, so the pixels are drawn like this, using 2 loops. I already have the capability, using the API provided by the OpenAI, to know which pixels actually contribute to the user and which pixels are just the background. So what my advice, I'll just explain how I measure how tall the user is, and the same concept applies to other body parts. So just use this as an example. So when I'm traversing the array of pixels, I first encounter a user pixel. Okay, so this user pixel, X and Y coordinates are saved, and this is the top and the first user pixel. And then I continue traversing until I reach the last pixel with of course, if I assume this is the X, I assume this is the Y, I just try to find the last pixel with the same X coordinate. So I find the great Y with the same initial X that I saved right here. So if I have the 2 pixels, I can draw a straight line, and this would show how tall the player is. Okay?
But you will never get to this point at the bottom because the legs are spread.
Sorry?
You will never get to this point at the bottom because the legs are spread. They're not together.
Yes, but I'm traversing this array, so I find here this is the user pixel.
It's that, and not
Yes, but it's the same level.
Okay, yeah.
So I already have the x-axis, I just want to find the y.
Okay.
Yeah? So I just find it here, I'll just draw a straight line. That's mainly it. Different body parts are found out using the same technique. Okay? I'll just show you a video of is this algorithm working? As you can see, first I have to do this specific pose, which is the calibration pose. This is imposed by the drivers that I'm using, which is the OpenAI Ignite. I have to first start any session with this pose so the system can recognize my different joints, and then I can do whatever I wish. So as you can see here, it's writing calibrating, and then it's tracking. So the calibration actually succeeded. What I'm doing now is standing in the measurement pose, as I told you about. And I issue the command measure, and then, as you can see, this is the different body parts that were found. Actually, there's a line here, but I think it's lost because of the video quality. But yeah, so a line here, and this is how tall, and this is the two sides, and this is the waist. And here is the results. I'm sorry it's blurred, the quality is lost due to compression of the video. As you can see here, I'm just saying you're 184 centimeters tall, your waist distance is 31, I guess. And actually those results are accurate to some extent. It of course still depends on the closing. Okay, so moving on. The coach perspective. As I said, the user is able to record his own custom moves. In this perspective, there is mainly two states. The live animation, no recording state, and the live animation recording. Live animation, it means that there's an on-screen 3D avatar that if I move my right hand, the on-screen avatar will move his right hand, and so on. And of course, no recording, I'm not recording, and recording, I'm just recording whatever the user is doing. So first, initially the user starts in this, of course, always starts in this state, which is the on-screen avatar. Is tracking the actual user and is doing the same moves the actual user is doing. But there is no record. I could issue the command record, and then the system will start recording whatever move I'm doing. So I'll just say record and do something like that, and then I will say stop. So just this gesture is moved. It's saved by the system after I say the word stop. After stop, I have two options. I can either record another move, or I can issue the command replay, which goes over the first moves that I say during this session and replays it using the on-screen avatar. It goes over them sequentially, so it's just like an array. I was a pointer at the first one, so I just say replay, it replays the first move. I say next, it goes to the next move. I say delete, it just deletes this reference to this move. I say replace, it will start recording over the current move. So actually replace is like a record, but not a new move. Record over the existing move, because I did it wrong or anything like that. This is mainly done, as I told you, the Kinect offers APIs that provides the joint position of all the different joints. When the record command is issued by the user, the system starts serializing those objects, those rotation matrices of each body joint, and starts saving them to the hard disk for later referencing, of course. When I say replay, the user the program just stops getting input from the Kinect and takes its input from the hard disk, from the already saved moves. Okay? Here's the video. As you can see, there's two screen avatars. The one labeled view is the one imitating the same moves as the user, and the coach is the one that will be playing the recorded moves by the user. I issued the command record. As you can see, it says it's recording. gesture that we just did. Just replace. So, the most important part, which is the gesture recognition. As I mentioned earlier, a gesture is a series of pose, a series of body pose. So, any move I do with my body over a period of time is considered a move or a gesture. What I wanted to achieve here is to have a recorded move, recorded by the user, or even comes predefined with the game, and have the actual player trying to imitate the same move. And the system would say if this move is correct or if it's not correct. As I just said, I couldn't use any in neural networks or any machine learning algorithms in that because the saved gestures are not already known. It's a dynamic system. I can just get the game and I will just want to record my own move, my own custom moves that it didn't came with the game, and I have to make the algorithm match this new move. So I couldn't use any training data or anything like that. So the solution I came up with is the following. Okay, so any body part I'm moving, it will either let's say we have the y-axis and z-axis. So y-axis and z-axis. So any move I make with my body, the angle, the two angles with the y-axis and z-axis will change. It will definitely change. It will either change in one or it will change in the two axes, the y and z. So what I do is the following. I start recording a move. As I mentioned earlier, I record the joint orientations, which is the rotation matrices of each body part in each frame. So if I have 20 different joints, for each frame I will save 20 different rotation matrices for each frame and second frame and so on. So I have all this data, and this is the moves that I want to match to the moves that the player is doing or will start doing. Okay, so I just label the saved one as a saved move, okay, and the player will start and tell the system that I want to compare what I'm doing right now to a saved move, which I will name it for just explanation purpose, the live move. So I have saved move and live move. What I want to make sure is that the live move would consist of the saved move. So everything that's done here is already done here. So what happens is the following: the algorithm runs. It's like I have two stacks or two arrays and pointers to the beginning of each of them. I start with the first frame. I try to find the saved move of the first frame in the new live move. If it's found, then I increment both pointers and try to find the next one in here. If I didn't find the first saved move in this live move, if it started at different times, then of course the first frame will not match the first frame here. The first frame here maybe is the 5th or 10th frame. So I'll just increment until I find this. If they both match, I'll just go over and go to the next saved frame. Next saved frame, yes. Okay? Here?
You said a lot of information. I think you either had like a diagram for that. Or
Yeah, I can.
But the idea is, can you just say again why make it clear why you were trying to do that?
To what exactly?
Like now you designed the actual move.
Yes.
And now you move to the next step. What was this next step for?
As the next step, I'm trying to do a live move and compare that to a saved
Why?
move to have the person training experience, so the system can tell.
Feedback.
Yes, the feedback. The feedback.
Yeah.
Yes, the feedback is mainly built using the gesture recognition system. So the system would observe the new move and the already saved move and would say if they matched or they didn't match. So the comparing actually happens as the following. For each frame, I get different body parts and I compare each and every part with each other. So I have the first frame of the saved move and the first frame of the live move, and I compare the hands. What are the angles of this hand with the y and z axis, and what are the angles of this hand with the y and z axis? And there's an error value. If it passes this error value, then this is not the correct pose, this is disregarded, and I continue over. If it didn't pass, then this is a match, and continue with the other body parts. If all body parts are matched, then this frame matches another frame in this, and I continue working on until then. Okay? It's also worth mentioning that the initial version I did with this algorithm took a lot of time to complete. It took about 40 seconds to just compare a simple gesture to find out if it matched or it didn't match. This was mainly because there was a lot of hard disk access, because everything is saved on the disk. The live move and the save move, both are saved. So each time I have to make an access to the hard disk, which is slow, and retrieve the data and compare them and find the angles and so on. It was later on optimized by first getting all the data from the hard disk into the RAM using an array or a vector of some type, and the algorithm would run on those two vectors which are found in the RAM. So the disk access was only done once in the first part of the algorithm, and then the algorithm just runs on the arrays and vectors. So the time was improved. It was actually now it takes about 1 to 2 seconds. Okay, so here's the video. As you, as you can see here, this is the angle that my elbow is doing with the y-axis, and it's the same for the second hand. Those are the angles, and coupled with the angles of intersection between the z-axis that are compared between the two gestures. You should remind record, start the recording session. The record is a simple gesture. So it allows the system to recognize the move I did. Check. And I'm asking you to check. Was it matched or not? And it says that the gesture matched what I did with the same move. I start another compare session. Start compare. This time I'm doing another gesture. And compare. Gesture didn't match because the gesture that I did, which is this one, didn't match with the initial ones that I recorded, which was just raising my hands. Okay? So,
I thought the coach is the one who gives, is for time purposes, the coach now giving feedback?
the feedback is just.
You just say,
yes, just state. It should and can be improved to just provide live feedback as I'm doing the move, not after the move is done. But initially it was.
It was more than 1 second.
Yes, but there's just
Did you measure it?
yes, about 1.5 seconds. But the voice recognition system takes some time to recognize the word, and
okay. Do you know the total?
it's a total now. I read it really.
Plus the voice recognition?
No, just the 1.5 seconds is the computation of that word. So the evaluations for this system, it's using a selected number of few users, about 7 users. They all came with different backgrounds. Actually, different backgrounds in regards to their fitness levels, to their work environment, to whether they were doing already work at home or just not going to the gym or by going to the gym. The evaluations were done on 5 different sections, with each user going through each of them in order. The first section was just the background section, where the user was asked, do you know the Kinect? Will you buy the Kinect if you know it for $150? Do you do exercise at home? Do you go to the gym? And things like that, to just know where the user came from. The second section would make the user test actually how the calibration is done and how the movement, how his actual physical movement are translated onto the system by the on-screen avatar, and how well or how not well, how is it working. The third, fourth, and fifth sections were each and every one of them for the gesture recognition, for the body measurements, and for the coach perspective. Each user was asked to evaluate each of them, and the result will take. Okay, the results weren't actually very good. Everyone liked the idea, but unfortunately there were problems with the calibration and problems with the motion detection of the user and the translation of this motion detection to the on-screen avatar. The problems reported by the user were mainly due to two problems. First, the driver used, as it was the open source driver and was not provided by Microsoft, it suffered a lot of inefficiencies and it wasn't very accurate. And the other problems were just bugs that were detected during the evaluation phase, which is near the end of the whole project phase. It will not fix. The future work. Okay. On June 16th, the day I submitted my thesis, Microsoft released the official SDK. Unfortunately, yeah, it has a lot of advantages over the one I used. It provided a way better accuracy. It didn't require the user to stand in a specific pose, so just stand in front of the Kinect and to get my position. It provided access to the microphone found in the Kinect. It provided access to the motor and tilt, so I can just move the motor up and down to have the perfect picture. So this is definitely a step that has to be done in this project to have better results, of course. There's also the mini games. The mini games were suggested by some users, and they can actually be found in the commercial games found already on the Xbox 360 that have the same idea that this project has. The idea of mini games is just to break the boredom of doing exercises. So instead of doing just sit-ups and crunches and things like that, I'll just make them every couple of sit-ups. I just make a mini game, something like cycling, something like boxing, something like just jumping, and imitating that I have a rope, things like that, just to break the boredom. Also, a social platform can be developed. The social platform would help the system in two ways. First, it would help the users interact with coaches. So if I'm a coach and I'm using the system, I can just create my own moves and perfect them. So they're just coming from a certified personal trainer and just post them for other users to maybe download or even buy to make a commercial benefit for me. The other important part is that if each user has an online profile, tracking his or her progress over time, so when the user triggers a body measurement session, the resulting body measurements are just automatically sent to the social platform, so I can just open any time and see how my body was different during the month, during the week, and compare this with the friends. With my friends and other people, things like leaderboards and the well-known things done in games that provide a competitive edge that makes the users have more motivation to work and more motivation to burn more calories. Okay? So that's mainly it. Any other questions?
Well, first of all, I'm happy that you reported evaluations, even though the evaluations were kind of bad. Yeah, so that's congratulations. Looking at the evaluations, which extent of this of the result of the evaluation was due to your UI design or your concept of what you were presenting, and what was the percentage of actual bugs or actual things that were of technological nature?
You mean the problems due to the driver?
Problems due to the driver,
Yeah.
due to bugs, or bugs that you still had in your software, and which ones due to the way you presented your concept and the UI design that you actually did in order to provide feedback, for example?
Yes. Actually, I didn't really work a lot on the UI. As you can see, I didn't even change the on-screen avatar. So I thought that this UI is irrelevant to my project. I mainly worked with algorithms for it. My approach to the algorithms, I think, was actually working. There was no problems in it. Most of the problems were due to the driver I'm using doesn't track the head. So users would just try to move their head, and the on-screen avatar wouldn't move their head. It didn't track fingers. It had problems with the legs. tracking the legs. If the legs are not shown, so if I have my hands over my legs, the hands of the on-screen avatar would tremble and wouldn't be working fine because of problems with the.
Okay, what else when it comes to the UI design would you change in order to make it more appealing and more clear?
Yeah, first of all, I would change the avatar, but actually that wasn't easy for me because I couldn't find a free 3D model to use, and I don't have any experience in 3D modeling, so I had to keep that. This is mainly the first thing to change.
Anything else regarding the process, regarding how you display information, how you give feedback, all these sort of things?
Yes, of course, this can be changed. Of course, mainly about the feedback system, as I was telling Dr. Fatma, the feedback system needs to be enhanced to be live feedback system. So instead of recording my move and the algorithm running offline to compare it both, the system would run as I'm working. So if the actual move is like this, and when I'm doing it, the system would tell me, it's like a meter, how close I am to the gesture already set.
So your algorithm right now, the feedback that you give is it's binary, it's a mesh.
Yes, it's zero now.
So I calculated actually the percentage and the threshold.
Yes, a threshold for each. Yes, a threshold at the end of the day.
What's the threshold you're using now?
25, 20. I'm sorry, 20, 28.
20%,
20%. The difference between the angles.
Okay.
So just the angle. Just the
Plus minus, so 40 or plus 10 minus 10?
No, it's actually 20 constant.
So plus 10 minus 10.
Yes.
Alright. Well, actually, let me say that the answer when you said that you did not care about how the UI is like, I don't mean, or at least I didn't take the question about how the UI like, how this busy or not.
Yeah.
How do you think about getting people to design and all of that? How do you do that?
Yes, yes. I just meant the buttons and the
How did you
address
think,
and the environment.
for example, the decision to do the voice, the decision to do the
Yes,
design, and how you do the design,
Yes.
and how to
Yes, yes, of course. I didn't mean that. I understood the question wrong.
Because that's a very good question, because think about it. You could have gotten a bad feedback because of the way you presented your solution.
Yes.
You have a good idea. They also think it's a great idea, but maybe the way you present it to the user, it's all about the user in the end, right? Was not the right way. It's not because I'm so happy your argument is correct, and I'm sure you've done a great job. I have no doubt about it. However, you should think, for example, when we thought about, let's say, a coach designing a move.
Yes.
What did we do at that point?
Yes, we had a lot of
We
iteration.
brought people who are
Yes.
coaches in real life to give us feedback how they want to design something like this. And, and the rest, the same thing with the rest, and you always take people feedback.
Yes.
So you're actually taking feedback to know how to do things, but to not care about how things
How
work.
things will just look. I mean, just
But it's
how
very
pretty.
important to, I just think that you should not say that the UI is not important for you, because it is.
Yes, it is.
Not the color or how, at this moment, but how you design things, the conceptual model of the system, so not just.
By UI, I just meant how everything looked as the colors, as a.
Just a simple thing, when you present your first video with the first feedback and it's matched or no match, you knew where the information was displayed, in which way, in a textual way, but none of us actually saw it. None of us actually knew where we should look at when we see the feedback. So that's one thing that what recommend. You can display it textually, you can display it with color, you can
It was
display
actually
it with
displayed textually in the
yes,
upper right
but no one knew.
left corner.
If you have to explain to someone where to look at to get feedback on your movements, your system isn't working.
Okay.
For that, from the person's perspective, because if there's no feedback, the system isn't working.
Yes.
And if you have to search for feedback with a magnifier glass,
No, it's just because I didn't remember the whole idea of Kinect is to make people, and the whole idea itself, the whole idea of personal training, you just want some people who are lazy like myself to do some sports and not, so you have a team of people who are very interested in that system, I have to say. However, I don't want to feel a burden, and we are worried sometimes that the feedback coming is not because of this, and you might get, I'm very happy you actually said about the evaluation, even though it was bad feedback. But it would be nice done to affect the whole idea. You know what I mean?
It was
So-
unrelated to the idea. As I said,
That's the
everyone likes the idea. So when you're just talking and just explaining the idea or doing anything, you just
So
yeah,
it
wow,
should be your
this will
main
be-
concern. Yeah, it should be your concern. And you know what? It could affect in the future the way you actually do things. How you want to do things in your specific system. You might even change the way it's being done. For example, when it comes to matching, if you want to do this feedback thing, the whole matching
Actually,
that you have now might change.
Actually, one thing that I heard through this project, one thing I did wrong actually through this project is that I was finished developing and then started evaluations, and that was I don't think that was correct for me. For
But
me
you
doing
were
it.
doing the evaluation with it, but informally.
Yes, informally, exactly. I didn't do it with a lot of people, and doing evaluation with a lot of people coming from different backgrounds opened my mind to another perspective. So if I would just do it over again, I'll just do a formal evaluation for each feature that I've done with.
I appreciate that you didn't have much time and you learned a lot of things from scratch. I do appreciate that so much, and you've learned so many things totally. You had no documentation or help or anything when it comes to technical things. So I don't have a problem that things, for example, the evaluation, we give much information about the evaluation. You said it was bad, but you should have had like either specific quotes
I
from
was just
people, specific the procedure. Yeah, you know, the procedure of what you've actually done. I was very interested because I wasn't here during this